Our next topic of discussion is going to be on gases, and specifically characteristics of gases and how they relate to pressure, temperature, and volume. So we're going to begin talking about the pressure of gases, and you see this covers pages 361 to 368 in your textbook, which would be very good to read. So the definition of pressure is force over area. How much force is being applied to a certain area? And we're going to put units to this force in this area in a few minutes here. But if you look at the examples given in the slide, you have different types of shoes. You have snowshoes, you have high heels, and tennis shoes. And it's asking us which shoes create the most pressure. Well, that would be the shoe with the smallest area. So if we look at the snowshoes, snowshoes are huge. They have a very large area, very large surface area. And so if you have a large area, you would have a large denominator. That would make your pressure very small. And the goal of snowshoes is to keep you from getting trapped in the snow, from going down into the snow. So you stay on top of the snow. So you want a very low pressure. So the snowshoes would create the lowest amount of pressure. The high heels, the heels on the back have a very small area. So a small area would create a high pressure. And so those would be the shoes that would create the most pressure on the floor or whatever you were walking on. In a balloon, and specifically with gases, what determines the pressure is the force of the gas molecules pressing against the inside surface. So when you see an inflated balloon, what you're seeing are the gas molecules that are bouncing on the inside of the surface, creating a pressure and thus inflating the balloon. So the pressure of the balloon is determined by the area on the inside, but also by the force of the gas molecules. And so the more molecules you have in there, the higher force is going to be pressing on the inside of the balloon, aka the higher pressure. Now, how do we measure pressure? Well, it's measured in something called a barometer. And the barometer was invented by an Italian scientist named Enrico Torricelli back in the 1600s. And anytime you listen to a weather forecast or you get online and look at the National Weather Service forecast, they're always going to measure the barometric pressure. And the barometric pressure is essentially a measure of the weight of the air that is pushing down on us. Most of us are familiar with swimming pools, and when we go diving in a pool, the farther down that you dive, the more pressure you feel on your ears. Well, that's because you have more water on top of you. The weight of the water is creating pressure on our ears. We have that same weight of air on top of us. There's about a 50-mile column of air that's pushing down on us. We don't normally feel it because we're genetically engineered to live in this environment. But it is producing a pressure. And so a barometer is designed so that we have this vacuum-filled tube. It's a glass tube with no air in there. And it's resting in a pool of mercury. And remember, mercury is a liquid metal. And as the atmospheric pressure pushes down on the mercury, it forces the mercury up into the glass tube. So that the more pressure we have pushing down on the mercury, the farther the mercury goes up the tube. And a lot of times when you look at the weather forecast online, they're going to measure the barometric pressure in inches of mercury. And it literally refers to how many inches that mercury column rises above the surface. In science, we're going to use millimeters of mercury as a metric unit, as an SI unit. Now, the average atmospheric pressure at sea level measures 760 millimeters of mercury. As you move into higher altitudes, like if you would go into the mountains out in Colorado, the atmospheric pressure decreases because you have less air on top of you. So if we look at a diagram here, and this gives us a little better perspective of the air pressure on the surface of the Earth, we have this column of air that continually pushes down on us. And so the farther we are towards the center of the Earth, i.e. sea level, you're going to have a higher atmospheric pressure than you are at the top of the mountains. Okay, and if you were in class and remember the aluminum can demonstration where the aluminum can was crushed, that represents the weight of the air on top of us, and it was the weight of the air that crushed that can. Well, in our bodies, we have pressure that's pushing out against the atmospheric pressure, specifically at 14.7 pounds per square inch, which is the average atmospheric pressure. Okay. So this diagram illustrates the atmospheric pressure in a way that can allow us, I think, a little more understanding of something that we don't normally assume is there. So refer back to that slide in case we need that. And this is also why whenever you're in an airplane and you're taking off in an airplane or landing in an airplane, or sometimes we're just driving through the mountains going down to Florida on spring break, you feel that popping in your ears, because it's through our ears and our eustachian tubes that our body equalizes this pressure. So as we're going up in a plane, the air pressure around us decreases, and so our body adjusts for that decrease in pressure. And so that's why we feel that popping in our eardrums, because it can be very painful when the pressure inside our bodies is not equal to the pressure outside our bodies. Either way, if it's too high or too low. And some people, when it rains and we get low pressure systems moving through, some people develop headaches because it's low pressure on the outside, and our blood vessels can actually expand on the inside of our bodies due to high pressure, and that can cause headaches or inflammation in joints like knees and elbows. So that may be a reason why you feel that popping in our ears as you move up or down in the atmosphere. So here's another picture of a barometer showing you what happens. And then this is an aneroid barometer, which is more mechanical in nature rather than the mercury barometer. Then we have something called a manometer, which measures gas pressure in a container, such as maybe if you had a propane tank on a grill, you might have a manometer. And this basically works so that you have a U-tube manometer. This is the original U-tube right here. If the pressure is greater on the inside of the tank, it's going to push the mercury level down in the U-tube. So we would look at this and say that the pressure is much higher in the container than it is on the outside. When the gas container is empty, the levels are going to be equal, because it'll be equal pressure on the inside and outside when it's empty. If there's a greater pressure on the outside, then this level would go up here. Okay, so that's the difference between a manometer and a barometer. Just a couple meters for you to understand how they operate. That one we're not going to worry about. Okay, the important aspect are the units that you're going to see an awful lot of. And there are a number of units that we use for pressures. As you can see here, this represents a kilopascal, as you obviously can see right there. This represents atmospheres. This is millimeters of mercury. This is torr, named after Torricelli. And PSI stands for pounds per square inch. All of these numbers in units are equal to one another. Oops. Meaning that 101.3 kilopascals is equal to 1 atmosphere, is equal to 760 millimeters of mercury, equal to 760 torr, is equal to 14.7 pounds per square inch. All these numbers in units represent the average atmospheric pressure at sea level. And your job is going to be able to convert between these different units, because later on in the chapter I'm going to give you some equations that you're going to have to put pressure units into, and they're going to require certain units. You're going to have to put in the units of atmospheres, and you may be given a unit of pounds per square inch, or PSI. So you need to be able to convert between these units, which is not too difficult, but requires practice. So please become familiar with these units.